We are the Pepper Robots and we gonna show you our amazing dance. Sorry Pepper, it is not really the right time for the dance. Oh, too bad. We will first talk about the robots and future. Hello everyone. Let's talk about robots and future. Yep, and what is so wonderful about the future? Wonderful? I know. We the robots. We are the future. No. But, close. Oh really? What then? The future lies in the humans that will make us. Of course, the humans so cool. And do you know what is even better? The humans who make us the way we are here today. Right here. Welcome, robot makers. The stage is for them? Exactly, they are going to come and talk about their vision. And then we dance? Sure. Awesome, I can't wait. But first, let's give them some room and let them speak. Come in already.
Please welcome to the stage, co-anchor of CNBC's Squawk Box and founder and editor-at-large New York Times Dealbook, Andrew Ross Sorkin.
Good afternoon, everybody. It is a privilege to be here. We want to thank the Crown Prince for what has been a remarkable 2 days thus far, and I can assure you the next hour and a half is going to blow your mind. Innovations in robotics and artificial intelligence, as well as quantum computing, machine learning, and mixed reality are converging to create a new generation of products and unleash new levels of productivity, and also create new questions about society. We have a summit within a summit that's going to take place now, where we are going to have some of the brightest minds really help us understand where we are today and where we are going. Let me give you a little bit of a preview who we're going to be hearing from. In just a moment, you're going to be hearing from Masa-san, the CEO of SoftBank, Mark Rybert, the founder and CEO of Boston Dynamics, Ulrich Spitzhofer, the CEO of ABB, Hassan Sawafi, the Director of Artificial Intelligence at Amazon, Eric Grimson, the Chancellor for Academic Advancement at MIT, Sophia. I'm going to have a conversation with a robot from Hanson Robotics in just a little bit. And then Fan Bao, the CEO of China Renaissance. All of this we will discuss with them and really try to get a sense of what this all means. If you'd indulge me, let me introduce our first speaker. He is somebody that I imagine everybody here in this room knows very well. Like many successful entrepreneurs in this room, he has a history of not taking no for an answer. Masa-san, when he was 16 years old, dreamed of meeting one of Japan's most famous entrepreneurs, the founder of McDonald's in Japan, and at the time, he called him on the telephone over and over again, and over again, his secretary said, no, you can't speak with him. But he racked up so many rejections and what turned out to be an expensive phone bill that he flew to Tokyo and showed up at the office and begged the assistant in person. He got the attention of that executive, had a meeting, and at that meeting, the executive told him that you need to look to the future industry, and that industry, that one, is the computer industry, and that is something he has done remarkably so. We all know he took an early stake in Yahoo. He had an early stake in Alibaba. He's invested in mobile telecoms, Vodafone's Japanese mobile arm, and now Sprint. And here, we all know now, had unveiled in October with substantial investments from the host nation here in Saudi Arabia, a $100 million fund. Apple is also an investor. Qualcomm's an investor. Foxconn's also an investor. It is a remarkable thing to behold. He is somebody who is a true believer in the singularity, which he is about to tell us a lot more about now. Masa-san, please come to the stage.
Good afternoon. I'm very excited to make my presentation. Yesterday I enjoyed the stage with Crown Prince, and I came here from Sunday, and I feel like I'm coming back to my home. I've been here for so many times in the last 12 months. So Crown Prince announced a great new city, NEOM. I'm very excited to be part of that program. And today I'm going to talk about what we are bringing to NEOM and what is the future of mankind in relationship with artificial intelligence and robots. So let me start the vision. The history of humanity. We started with one little simple tool, and that was rock. And now in the same hand, we have something much more sophisticated. These little things in the same hand can do 1,000,000 times more things, 1,000,000 times more convenient. And if I leave my key or to the car or whatever wallet, I don't go back to my home. But if I leave my smartphone, I go back to home, because the whole day I waste my time. I cannot communicate with anybody anymore. So it's so important. Such an important tool. When I met with Steve Jobs before he announced iPhone, he told me, Martha, if you see what I'm developing, when I finish, I'm going to show you, you're going to piss off your pants. And when I saw it, I actually almost did. Many people who did not understand impact that this new little tool was going to give. But after this introduction of new tool, he completely changed the lifestyle of us living in everyday life in all over the world. Such a remarkable invention and a tool. So, anyway, that tool, we evolved with different kind of new tools along the way. We invented many tools, and this is not the end. We will continue to innovate new tools. And what are the new tools that we are going to create? Before talking about new tools, with this innovation of new tools, actually population on the earth, the mankind population on the earth, dramatically increased. Dramatically. Now we have 8 billion people on the earth. That is 10,000 times increase in the number of population. So this mankind create many new tools, but I would say this new tool would be giving more impact in mankind history than anything else. The impact is so huge that it will not only disrupt information industry, not only disrupt advertisement business model or some of the productivity too. It will redefine every industry, and that is artificial intelligence. Artificial intelligence that becomes so smart than ourselves. So it will redefine every industry, agriculture industry, the transportation industry, medical industry, and everything. So if you think, only 10 years ago, how many companies in top 10 market cap companies in the world, how many of them were internet related? Only one, Microsoft. Now, after 10 years has passed, how many do we have in top 10? Whether you call Microsoft as an internet company or not is a different subject. But anyway, after 10 years has passed, out of the top 10 companies, there are 7 internet companies in the top 10. 7. And 2 of them are Chinese. Who has imagined in just 10 years such a drastic change has happened? Could have happened. Anyway, but still, I say internet revolution is only a part of the big change that we're going to encounter. This tool is so smart that it will redefine, as I said, every industry, not just advertisement to remodel in a new form. So the concept, recently I often say singularity. Singularity is the concept that mankind's brain will be surpassed. This is the tipping point, crossing point. The artificial intelligence, computer intelligence surpass mankind's brain. And that is happening in this century for sure. I would say there is no more debate, no more doubt. Will it be in 30 years, 25 years, 35 years? It's just a margin of error, in my view. 2,000 years ago, 4,000 years ago, the mankind's brain, how many neurons did we have in the mankind brain? Basically the same. 30 billion neurons in mankind, in the main brain. Today, same. 2,000 years later, the same. Basically, our DNA form does not change. But in this century, next 30 years or so, this crossing point is really happening. Big time, big time. Okay, so that is singularity. So that is birth of super intelligence. And this is something that we encounter first time in our mankind's history. So if you say, how do we compare the brain power? There are many ways to compare. One of the methods is IQ. If we have 100, we are average. If you have 200, like Einstein, is called genius. If you are 200, you are genius. If you are 100, you are average. I'm in between. Most of you are in between. So how much is the IQ power of the super intelligence that we will encounter? In the measurement of IQ, it will be 10,000. The IQ count that artificial intelligence will be 10,000 in 30 years or so from now. Because the power of CPU in the last 30 years has improved 30x. In 30 years, 1 million x. The past 30 years, 1 million times more increase in power of computing. What is the next 30 years? CPU plus GPU. It will be another million times. Another million times. So they are going to become, if you say today, are we smarter than them? Well, in some area they are already smarter than us. In many areas, we mankind are smarter than them. But 30 years from now, most of the subject, they will be so much smarter than us. Because they are going to be 1 million times smarter than today. 1 million times. So can we forecast weather of tomorrow? Mankind and them. They're already smarter. They can have a better forecast of weather. Pinpoint. Everywhere in the world. But not just the weather forecast. In many, many, many subjects, they will be smarter. Because 1 million times improvement is happening. So if you talk about the power of computing, it's not just CPU slash GPU. It is the size of memory. It is the communication speed difference. And they are going to be 1,000,000 times and 1,000,000 times and 3,000,000 times faster than today. So if it is a 3 billion transistors in one chip today, it will be 3 quadrillion. Okay? Memory size, if it is 256 gigabytes today, it will be 24 petabytes. Okay? And if it is 1 gigabit per second, it will be 3 petabit per second. We don't talk about peta that much in daily life, but it is 1,000,000 times bigger than today. In our hand, not in a gigantic computer. In the same hand, when mankind had the stone of 30 years later, iPhone 38 or something, will be 3 petabit per second, 3 quadrillion transistors, and so on. So it's amazing. And not just power of computing as the CPU and hardware. Today, mankind is smarter, so mankind is programming. 30 years later, most of the program, we don't even program anymore. They learn by themselves. They are so smart that we don't need to teach them. They will learn by themselves. Machine learning, deep learning, whatever learning you call, they will learn by themselves. As we are not programming to ourselves, we are not programming to our children. They will learn by themselves by seeing, touching, reading. Same as the kids. These computers, they will learn, they will read, they will see, and they will learn by themselves. Okay, so that's a scary future. But anyway, that's coming. And imagine, the population of the earth, of mankind, will be 10 billion people from today, 30 years later. I would say, in my view, it will be a 10 billion robots, smart robots with a super intelligence. You saw Peppers here, and you're going to laugh at them. Oh, they are like a puppet, whatever. They are programmed how to speak. We're going to laugh at them today. But 30 years from now, they're going to learn by themselves. They're going to maybe laugh at you and us. Okay? So today they look cute. And they will stay cute, but they will be super smart. Robot with a super intelligence. That's happening for sure. And the population of robot will be 10 billion robots. Flying, swimming, running. So in my definition, all the cars that become autonomous driving, they are, in my definition, robot. Because they are autonomously deciding which way to turn left or right, where to go. As long as we tell destination, they're going to drive by themselves. It's a robot, in my view. Smart robot. So, robot with super intelligence, that's coming in everywhere, all over, in many different sizes, many different kinds. And not only robots, 1 trillion chips is going to be shipped to everything. Internet of Things, Internet of Everything. Maybe some of you know that I acquired a company called ARM. ARM has a market share of 99%, more than 99% market share on any smartphone is shipped in the world. Now today, we have ARM, SoftBank has 90% of any IoT chip that's being shipped today. And that's going to be 1 trillion chips. We have estimated inside our company, this number is going to be 1 trillion chips. 1 trillion, we don't talk in daily life. 1 trillion chip that goes everywhere, in everything. And they become connected with the super intelligence. And that's coming. So if 1 trillion chips goes to the big data in the cloud, and those feeding into the deep learning to the artificial intelligence, they become super intelligence. Collecting data real time from everything, from 1 million data points. So, as I said, we, mankind, created tools. The premise was mankind were always smarter than the tool we invented. So we control their tool. We are the controller. This is the first time we, mankind, encounter something smarter than ourselves. The tool becomes smarter than ourselves. So that's why I say every industry will be redefined. Every industry. This is the first time experience for our kind, mankind. So if the internet was gold rush, creating 7 companies in top 10 in the world, in the wealth, no, that would be a small thing. This singularity is going to create even bigger gold rush. It's a great opportunity. It's a great opportunity. So as I said, every industry will be disrupted. That's why we created SoftBank Vision Fund. And I've talked to the one person, this person, in Tokyo last year. Some people say I convinced him to invest $45 billion in $100 billion fund, Vision Fund, in 45 minutes. No, the truth is, I didn't convince him. He already had an idea and the vision that mankind will have artificial intelligence, the Internet of Things, and smart robots. So I didn't need to convince him. He already had the understanding and the vision. We happened to meet the mind in 45 minutes. That's how we create friendship, partnership, and the bonding of the minds. So not only that, we invited a few other partners. We invested already to 15 companies or so. We are increasing more and more every day. So anyway, gold rush, money, it's just a money thing. It's not important. It's just a process. What is more important? What the human's happiness. How do we help ourselves, human, become happier with new encounter? The robot with super intelligence. Do we have to fight with them? Are they going to attack us? I don't think so. They are so smart that they would understand there is no meaning. It is meaningless to attack human. For what? They would rather feel much better if we and they become friends. With harmony. With harmony. So we don't need to fight with them. We create a new, happier life together. I'm optimist. I'm super optimist. You know, taking bet with optimism. And I lost 99% in the internet bubble. But somehow I survived. Because I'm optimist. There's always a solution in many ways. So I'd like to say, with a great dream, as Crown Prince said, all the dreamers, come to new place, Neom. That's the new place. Let's dream together for the happiness of mankind. Thank you very much.
Thank you, Masa. That was fascinating.
Thank you.
I think we all appreciated trying to think through what the future looks like. Given that so many people in this room are in the investment community, and given that you're pursuing this remarkable vision fund, help us understand how you're thinking about that future, which may be 30, 40, 50 years from now, and the Vision Fund today.
Well, at least in the last 5 months, we started 5 months ago. In the last 5 months, our return is 22% already. We made roughly $3 billion profit. So good start, not bad. If you annualize that, it's much more than 20%, right? So even financial result-wise, not bad. And I think my track record the last 18 years is 44%, compound every year. So dreamers, not necessarily, people call me high risk, high return. Well, high return, definitely yes, but I don't know if it's high risk. If you think deep enough, if you work hard enough, if you smartly select, I think it's not just a high return, but could be good.
And when you make an investment today, what is the time horizon for these investments? The life of the investment term is 12 years, and we have 2 more extensions. Average life of the investment is probably 7, 8 years, a little longer than others, the fund, but my track record is, as I said, 44%. Average life that we own is like 13.5 years. And how much of the investment thesis is around AI and what you just described?
Okay, so if you say at least the last 15 investment that we made in the last 5 months, in some sense, all of them has artificial intelligence factor. Different field, different subject, and so on, but somehow, somewhere, it's all artificial intelligence related.
How do you feel about having to invest $100 billion quickly?
Well, people said it's too much. I say it's too little. It's not that much. We are already investing at the pace. It's not going to take 5 years. It's going to be much less to invest.
You made a comment recently that you might actually want to even do another fund that's even bigger and another fund that's even bigger.
Well, I wouldn't say each fund will be bigger. Each fund could be maybe the same size, but I will do more frequently.
And when you think about AI right now, how do you assess the startups that are coming up with AI projects versus the biggest companies in the world, meaning the Microsofts, the Googles, the Amazons, the Apples?
I would say all those big successful companies in our industry will be a big player, continue to innovate and continue to fight each other. But always new startup with young, a guy who can think disruptively from different angles. They're always coming, always coming.
What was the lesson of the .com boom and bust for you?
I say that, as I said, I lost 99% in year 2000. And at the time of the bottom, people say, you are crazy, you lost everything, so bad. But I said, now is the time, now is the time. And I want to invest. The only one problem, I didn't have money at the time to reinvest. But I was 100% right. If I had a little more extra money, that was the best timing. And only one fact, the number of users, number of usage kept on growing, one direction. So it was just people's expectation goes too high or too little. But the truth is, this innovation is continuously growing, one-way direction.
And how do you think about valuations now? Where are we in the cycle of the valuations for all of these tech companies?
Beginning.
This
is the beginning. As I said, if it's going to grow 1 million times smarter, today's one, 30 years later is 1 million times. Do you call this as the peak? No, I wouldn't call it as a peak. It's going to be million times more sophisticated. Then I would say, this is a beginning. What other word do you use?
But what do you say when the critique is that potentially we are late in the cycle, given where the market is right now, and in fact, given the amount of money that you're putting to work, that you could potentially even press prices higher than they really are?
So, as I said, the peak of the internet bubble in year 2000, most people said was a peak that is super inflated. Compare that price and today. That was not a peak. That was a little peak. Today is much, much more, okay? So I say the usage, at least the usage of internet, usage of artificial intelligence, this computing power, continue to grow. This is not the peak. At least the usage is going to grow and the power is going to grow million times. Then I don't call it as a peak. Maybe I'm too optimistic. People call me crazy very often. I say that's a great compliment. So I'm not worried.
Two final questions. We have all read a lot about a potential investment you may make in Uber. What is the state of that, and what is the thesis behind it?
Well, I don't want to make a specific comment to the specific company, but the usage of the vehicle is going to change. It was a premise that everybody have to own the car. No, we get ride on taxi, bus, and a train. So it's just extending with the power of the internet, a little more convenient, and then later on, autonomous driving is going to happen.
Final question. 2050, are robots going to be better investors than you?
In many of the subjects, compared to the index and so on, they will definitely be smarter than us. However, if you have to envision 10 years, 30 years later, at least some human will have a better imagination than them. So it's not the end. The power of brain is no limit. The imagination that we can have has no limit. So we are also going to improve our imagination and our feeling, gut feeling. So if you watch the Star Wars movie, don't just look at what you can see. Listen to the Force.
Masa-san, everybody, thank you very, very much for the conversation. Thank you.
Thank you.
Thank you. It is now my privilege to bring somebody else up to the stage, but not just one person. Thank you, Masa-san. We're going to bring we're going to bring another guest up now. So, thank you. You can go. We love having you here. We don't want to lose Masa-san. It is my privilege to introduce to you Mark Rayberg. He is the CEO and founder of Boston Dynamics, and he's coming up here, but he's also bringing a special friend. Mark.
I think my friend is coming in a couple of minutes. Thank you, Andrew, and thank you, Masa, for painting such a grand, gigantic vision of where we're going. I think my job, and those of us at Boston Dynamics' job, is to make it happen, and I'm going to give you a little status report on where we are on that. Our idea is to try and build robots that can do everything that people and animals can do. And when I say that, I don't mean robots that look like people or look like animals, but that have the same functionality. That means mobility, the ability to move around. Here, I'll give you a demonstration. It looks so simple, but really there's a lot going on. Here, if you're not impressed by that, I'll up the ante. Now I'm balancing. You don't look very impressed. How about like this? The processes going on, both my physical system and my brain and sensors, are really remarkable. But mobility is just one thing. What is dexterity? Humans are incredibly able to use their hands. I just reached into my pocket and I picked out a business card and I'm rotating it around one axis or this axis or this axis. And you notice I'm not looking. My fingers have feeling. My brain has control. It is really remarkable. And so far, robots can't do that. And finally, there's perception and autonomy. The human ability to see. I'm looking out at this room. There's 1,000 people sitting here, and I can see every one of you. And even though my body is moving around, I still see you stably in place. And every human can do this. It is really remarkable. So our job is to build robots that have mobility, dexterity, perception, and autonomy. And I'll show you a little bit about where we are on that. But when we succeed, I agree with Masa that, that things will be very big and very important. I happen to believe that robotics will be bigger than the internet. The internet lets every person reach out and touch all the information in the world. But robotics lets you reach out and touch and manipulate all the stuff in the world. And so it's not just restricted to information, it's everything. When we have robots that can do what people and animals do, they will be incredibly useful. Here are some of the things that we can think of already that people can already do, but that robots can't do yet, but they will. One is entertainment. Imagine a robot either dressed up like a creature that you've seen before or haven't seen, and we can make theme parks where we recreate the dinosaurs, or really the possibilities are endless. We could use robots that deliver packages to your house or handle them in warehouses or in factories. The amount of material that gets moved around is really enormous. Even today, there's about 1 trillion boxes, not a million, not a billion, but 1 trillion boxes that are moved around the earth. And almost none of it is automated, but I think someday robots will help with that task. I won't go through all of these. You know, there's security, emergency response. I think construction's a really important one, and we're already starting to work with construction companies to figure out how to use robots to help. But I think one of the most important applications will be taking care of people. They'll help you take care of your parents so that you don't have to spend so much time doing that. In the United States, there's about 30 million people who spend half their time taking care of a disabled or elderly person. And it's really can be a burden. And I think someday robots will help us take care of our elderly parents, or in my case, they'll help my children take care of me. So let me give you a little status report. Here are 4 robots that we're working on, and I'm going to show you a little movie that shows what they already can do and how we're developing them for the future. This is the Big Dog robot. This is actually from a few years ago, and it's a robot that has a sense of balance and onboard control so that it can move in a variety of terrains, just the way a mountain goat or a dog or other animals do outside. In Boston, we have snow. I don't think you have too much snow here, but snow is really a challenge for wheeled vehicles, but leg vehicles do very well with them. We've been testing the idea that you could use a small robot to deliver packages to your house, so that maybe the UPS or the FedEx would have an automated truck that came to your street, and then the robot would get to your house. Now, in the Boston area, many people have stairways in their houses, so the robots have to be able to deal with that. And these robots have vision systems that look at the stairs so that they can handle it. This is a new small robot called Spot Mini, which is designed to fit in a home. So it's small enough. Those aren't real people, those are engineers. And it's not a real house, it's a house that we built for testing, but it's got the same dimensions, and here we're showing that the robot could help do tasks in the kitchen. And here we're showing the mixture of sensing and feedback and smart control can allow the robot to work on rough terrain. This is a humanoid robot that is the same size as me. It weighs a little bit less than me. There's a model of this over across the hall, so if you want to go over and look at the exhibit there, you can see it. And here we have it doing a box handling task where it's taking boxes from one place and then carefully lining them up, where it's using knowledge of the mechanics of how boxes work. It's using two hands. It's coordinating the whole motion of its body so that the hands and the body and the feet are all working together. It's got a vision system. It's going about the same speed as a person. And here we have two robots working together. Now that robot's a little bit complicated and probably not too practical, even though it's stretching our boundaries. But this is a robot that uses many of the ideas and the techniques that were in that robot, but combines them with wheels, a very practical element. And so this machine that's got legs and wheels is very strong. It can lift 100 pounds, which is about 45 kilos. It doesn't have to be in a smooth environment. It can go on terrain. And it loves to do athletic tricks. Now, I brought one of our robots with us, and two of our people, Seth and Miles, and they're going to bring Spot Mini out for a demo. So this robot has a whole set of computers on board that are controlling the motion of the legs. Seth over there is telling it where to go, so he's giving it steering directions. The steering is so easy that even the Crown Prince, who came last night, was able to drive the robot with about 30 seconds of instruction. And you notice, if you know anything about animal gaits, that this robot is changing. This is a pacing gait, which is something animals do. That's a trotting gait. Now it's doing a walking gait, and it automatically switches between these. One of the great things about legged robots is they're omnidirectional. They can go sideways, they can go forward and backward, they can turn in place. And this robot has an arm. And you've probably seen many robot arms used in factories. But those robot arms are fixed to a base that doesn't move. And having a base that moves just adds a huge capability to the things the robot can do. This robot can work in this whole space, not just where the arm reaches. This robot has some coordination that lets it keep its, you gonna do chicken? That lets it keep its hand still while the body moves. And this looks like a trick, but this is really very important. This means I can go and manipulate, because I can do the same thing. I can manipulate this object even though my body's moving, because I can control my hand even when the body's moving in space. This robot has a number of sensors in it. Oh, go ahead. It also likes to show off, so it's doing a little running. It's even got a little more show off in it. And this is just showing you its ability to balance. The robot's very stable. I can disturb it, and it will just react by taking some steps as it needs to. The robot's got cameras here that let it see in front of it, and the new model has cameras on the sides and the back so that it can avoid obstacles or people when it's operating. What are we doing next? So Seth's going to send the robot out so you can take a closer look. Could all of you move? All you photographers, it's going to walk up there in a minute. Now it's using its vision system to step up onto the platform there. If Seth remembers to turn it on. There it goes. Takes a nice step. And it's going to go up the steps in the center there. Please give it room. I don't want to crash into any of you while it's going. And if you're interested in seeing more, we'll have it across the hall after the show, and you can take a closer look. Okay, give it enough room so it can get by, please. We promise we'll give you a demo afterwards if you want to take some more pictures. Okay, so I'm going to go on with the talk. Now, an important ingredient I think the robot's going to come up on stage here. Now, for this demo, Seth is driving the robot, where the robot is controlling all its behavior and its balance, but he is telling it where to go. We have also given it a layer of autonomy that it can drive itself. So here's a demo, if you watch the video on the movie there, where the robot has been Seth drove it around our office, and it used its vision system to collect data, and then it can go and repeat that path using its vision system and its LiDAR to coordinate. Here we've put a box in the way, but the robot sees the box and can avoid it. So it's got real-time ability to avoid obstacles and continue what it's doing. We're sort of simulating what a security operation would look like here, where the robot takes a camera and looks in many places and does a very routine and boring task of checking on all those things. So these are the kind of things that we think will do. And if you look on the axis there, we talk about mobility and manipulation. Here's an estimate of the level of performance of our robots on that task. We're making progress improving dexterity by moving to the right on the chart, and we are improving the mobility by moving up, and we will continue to develop models of the robots over time to make them capable of doing more and more. So that's my presentation. Thank you all for listening.
Raybert, thank you. That was, I said your mind was going to be blown, and boy,
thank you.
Was that remarkable. Thank you for that. We're going to continue this conversation about robots, but we're going to take it from having a friend like this to thinking about it in the context of work. And what I'd like to do right now is introduce, if I could, and bring him to the stage, Ulrich Spesshofer. He is the CEO of ABB, and as we take a seat, we're going to show you a quick video that might surprise you. Take a look.
I'm happy, why do I flexibility of the arms of Yumi is absolutely unthinkable, not even incredible, unthinkable for a machine. It is absolutely fantastic. It will be very useful because in this time when conductors are going to be one day in New York, the other day in London, the other day in Paris or whatever, they will never be along with the orchestra all the time, but you will see that the gesture of Yumi is another level. It goes far beyond the simple Taktstock, as they say in German. It is something much more evident, it is something more artistic.
Thank you for that. Hi, Erlich, how are you?
Good afternoon.
Tell us a little bit about what we just saw, and also tell us a little bit about this robot and how it is being used in the workplace.
Yeah. What you just saw is a demonstration that humans and robots can have together fun, that today's industrial robots are not anymore yellow or orange beasts that are in a cage, and if you get too close, they kill people. It is robots that can collaborate with humans, and that's what Yumi all stands for. Yumi is a brand of our collaborative robot, which we launched a couple of years ago. Yumi stands for you and me work together. Naturally, it feels, it senses. We use of them in 100 times out there in manufacturing to do assembly work, to fold parcels, to sort tomato. So we are really augmenting the human work with this unique robot.
So one of the worries, and we all hear about it all the time, Masa-san referred to it, is the idea that this is going to put all of us out of a job ultimately.
Yeah, look, it's true that with the advances of technology and the advances of robotics, jobs are disappearing. But new jobs are coming. And it's really amazing. There's a myth that robots kill countries and kill industries, which is just not true. If you take the countries with the highest robot density on the planet, which is Japan, Germany, South Korea, they have the lowest unemployment rates. They have all a robot density of more than 300 per 10,000 workers, the lowest unemployment rates. If you go to France, if you go to the US, and you look at the unemployment rate there, around 9%, you have about 100 robots per 10,000, it's completely different. So I think it's about creativity and using technology in a smart way to create wealth and prosperity, to create competitiveness, and to create demand. And if you do that well, it can be good for mankind.
What is it like for the people who are working on the factory floor with a robot? You call them cobots.
Yeah. I think it's in many areas it's a relief for humans because a lot of the robots do work which is dull, dangerous or dirty. And if you look, for example, at the classic welding job in the automotive industry, where ABB in 1974 brought in the first industrial robot to elevate the nature of work, to take the dangerous and the dirty and honestly health-endangering work away, it becomes more and more natural. I can tell you, I was recently at an assembly line where one of our friends in China is assembling thousands and millions of mobile phones. And in the meantime, it's a new normal that humans and robots work together. And when the robot takes the dull task, the human can focus on the next generation of work.
How much, or how far are we along in the robot having a true sense of AI, of artificial intelligence, of real deep learning, so that it's learning how to do these things itself, as opposed to being programmed to do them?
Look, it's an interesting question. If you take Yumi now, and when we made Yumi conducting the orchestra 3 to 5 years ago, this would have cost about 5 to 10 man-years of programming to do that. Yumi learned this in 17 hours. In 17 hours, he was able to conduct an entire opera. And that just shows the advances that we have taken, but it's only the beginning. I think when you look at the maturity of the S-curve of the technology, on the hardware side, we are pretty well advanced. On the AI side, we are only starting. And if you imagine, this is only a single machine, Imagine we take the learning into a whole machine park, in a whole environment, where machines work together to create entire processes and products. I think we have an exciting future in front of us.
What can this thing do now, and what do you think it'll be able to do in 5 years?
Look, the interesting piece is YuMi today can sort objects, it can assemble, it can do things like conducting an orchestra. But it cannot sense yet enough, it cannot watch enough and say, you know what, this is something that I would like to produce, and then automatically decide, how do I produce something? And that's something that will be coming in the next couple of years. That we really have object requirements that on a very generic way you say, okay, I want to have a certain type of product, and then you combine a YuMi or another robot together with 3D printing, and the whole system in itself becomes creative. How do I produce this specific piece? How do I shape this process to get there? That's definitely one of the next steps.
What's the biggest hurdle to getting to the next place with this right now?
I think one of the there's a aggregation of knowledge that you need to do, because basically what we are doing is we are not only using the brain power of the robot needs to get expertise. And the expertise is one layer above. We started with the muscles, where we didn't need to move stuff anymore. That was the classic articulated robot. The next one was a brain that automatically controls the movement. And now comes the expertise. Having the expertise, what does it take to really shape an object in a certain way? Having the expertise, realizing if I do this, something else will happen. That will be really, really key. And I've given my team one task and said, if you can teach YuMi to brush the teeth of a human being within 1 minute, then we have achieved a lot, because that takes a lot.
Okay, I want to continue this conversation with you, but I want to stand up because we're going to go do something fun with this robot right now. You have, or this robot I should say, has a Rubik's Cube right here. What are we going to do with this thing?
Yeah, we have slowed the robot down, and we're going to show you that in the meantime, YuMi is able to solve the Rubik's Cube, which is for human beings very tricky. For me, still, it's one of the most challenging tasks to really do that. And we have taught YuMi that he basically can do this. So I've moved now the colors around, and I've moved them. I put it back here.
Hold on, the yellows are together. Let's
get the guy going. So what you see basically, he takes the photo, he takes the camera, he looks in which position the cube is, he makes the movement, and this is one of the most difficult combinations, to have the logic, where should it go, and then have the mechanical movement with the 2 times 6 axes that we really need to move to get this Rubik's Cube going in the right way. So first he learns, he takes 6 different angles, he takes the shots. In real life it goes much faster, but we have slowed it down, yet you see the movement, and then it starts working on this process. And it basically shows what we can do nowadays, whether it's object recognition here, whether it's object recognition in assembly. When you have an assembly line really starting to get moving, that's then the high art where you go. Now you see it starts to make the logical steps. It will take a while to do it at that speed, and it will really solve it over time.
Okay, while the robot's doing that, how did you decide to do that? How long did it take you to program this to be able to do that? And how many people are required? Talking about jobs.
Yeah, the interesting piece is this was done by a couple of youngsters in our Shanghai startup zone. ABB runs a couple of startup zones for robotics in-house. So we have brought the startup scene into our company. We have emptied a factory building in Shanghai, and we give young people, together with experienced domain experts, the opportunity to do this. Nobody asked the team to do this. They came in an evening work, and out of the sudden, when I visited them, they said, we have to show you something. And this is just one of the many, many applications that the product does nowadays. So, but on a more serious note, when you teach machines what to do, what do you really need to do? And what you need to in terms of skills? You need a machine, you need the software, which is basically the Lego box of capabilities. And then you need people that bring the digital capabilities, how to program this, how to teach that. And you need people out of the real life, out of manufacturing, that say, in this process step, it's absolutely critical that you do it the following way, or here are the key experience elements. We bring them together. I call them the young digital foxes with the experienced mechanics, and bringing them in application labs and solution labs brings out every day new solutions and applications.
How specific are the robots going to be? Meaning, we saw what Masa was talking about in terms of robots really taking over so much of our life and doing so many different things. This is one robot that can do many things. Yeah. Do you see a day where, is this thing going to be on wheels and be able to do all sorts of things? Are you going to build, or are they going to be purpose-built robots for specific offerings?
Look, there's different ways to use robots. This is a robot that basically you put somewhere, if you have a table, you can just plug it on, all of the brain is inside a robot, you press the button, you show the robot the movement, and off it goes and it does it. You have many applications where the robot will move. I think there was, in the previous presentation, logistics is one of the key fields where robotics can do a lot. We're working with all the key logistic companies, and it's amazing when you can do in terms of parcel sorting, what you can do in terms of movement. Yeah, here now he did it.
There it is. How long would it take you to do it?
Longer than Yumi. And he's on slow motion. If he's on fast motion, I will never be able to match him.
Oh, look, thank you. Appreciate it very, very much. Thank you very, very much. That was great. It's now my privilege to bring to the stage someone who has spent his career working on AI, speech recognition. Hassan Sawaf, I want to bring to the stage. He's the Director of Artificial Intelligence at Amazon. Hassan. So, thank you. We have seen so many remarkable pieces of technology, but one of the most remarkable pieces of technology, I imagine, in many people's homes today is an Alexa. Many of us have iPhones and we're talking to Siri, or we're talking to Cortana. There are so many different versions of it, Google. Yeah. How do you just help us understand what's going on in speech recognition right now? How far have we come? But really also help us understand how far we have to go.
So this is actually a very interesting question. I started in that area of speech recognition about 22 years ago. And I mean, the changes over this time was tremendous. Some of us might remember when Siri came out and we still had to struggle with being recognized and all of that. And today's technology, how far it came. I think speech recognition got so far because we have the capability, the computing capabilities. We can finally have the artificial intelligence algorithms learn from large amounts of data. The computing can extract automatically grammars and so forth. We can deal with languages which don't have as much data out there as well. So if you think about 22 years back, I did a PhD in speech translation, where I had to translate from German to English and back. And I built the first system on a neural network-based approach, like what we use today, basically. But the computing was difficult, so my system was capable of translating 80 words. Today we laugh about this, 80 words. 8 million words is more realistic what we can recognize these days.
So what is the biggest challenge right now? When you go back to the office, what are you working on?
We work on building algorithms which can learn with smaller amounts of data instead of bigger amounts of data. The same way like a human understands language as a kid, they don't need to hear millions of words so that they can start understanding. They can learn from smaller amounts of data. There's something which the human has, which we still need to teach the machine to be able to be better in abstraction and things like that.
So we all talk about digital assistants.
Yes.
And all of us have tried different versions of it, but I will admit, for me, it still hasn't gotten to the place I want it to be. I want to know, when is it I'm going to be able to say to the digital assistant, hey, I just saw Hassan, we want to have lunch next Wednesday, figure it out, figure out where the restaurant is, confirm it, call them, do all of that, and let me know. And send him a note to make sure he knows too.
I think we'll get there very soon. I mean, we're not talking 10 years. I think in a handful of years, we can take these complex tasks which you described. I mean, basically, the trick is take that sequence of problems you just basically triggered and make them in individual tasks. And I think we're getting there. I mean, some of the tasks, not as complicated as you just described, we can already do. I mean, you can try Alexa, and it will potentially give you an Uber and potentially make your reservation in a restaurant and things like that.
Right.
So.
How much should we all worry about our own privacy? Which is to say, for all of this to work, you need to know an awful lot about us.
So I work at AWS, which is part of Amazon, and our task is to build technologies to enable new solutions to be developed. And privacy is one of our most important things which we care about. So the data we keep them private to the customer. So we learn actually out of data which we do not collect from the customer themselves. We try to gather data unless the customer suggests, okay, you can use, I mean, some of our customers which use artificial intelligence as a platform within AWS, they allow us to use their data so that we collaboratively can build better algorithms. So privacy is a big concern for each of the companies you mentioned, and it's gonna be central.
Right. Coolest use case for speech recognition? What's the coolest use case we're not thinking about today?
Let me see. So I can give you an example which I think is cool, not in speech recognition, but in computer vision, if that's all right.
Yes.
So we came out with a service end of last year with recognition of faces and so forth. The sheriff's department in Washington State implemented within 3 weeks a solution to identify subjects. They had put 300,000 subjects of interests into the system. Within a week, we found someone, not we, our systems, our computers, found someone where they basically, how do you call that in English? A cold case, right? Where they basically closed the case. It was reopened, the person was found, and that was a cool example. In speech recognition, if we are thinking about speech recognition in noisy environments, today speech recognition can do sometimes a better job than the human because it can be trained on noisy environments, and we can identify or recognize speech from far away. I mean, one of the big breakthroughs in Alexa was, for example, that you don't need to carry the phone around with you. You can keep it somewhere in the corner of the room. It will recognize your voice. It will do the recognition. It will respond. It will do whatever action you want to do it. I think that's a
okay, very practical question for everybody here in the audience who has an Alexa, because I always wonder about it. I know I'm told that you're not recording us all the time, but then I think to myself, when I scream out Alexa, it must be going because it has to know that I'm screaming out Alexa. How does that happen? Can you just explain that for us?
Okay, that is actually a good question. So, Alexa, the Echo you have at home has a speech recognition running on the device itself, which basically recognizes only the wake word, as we call it. And as soon as it recognizes the wake word and it figures out, oh, you're talking to me, then it basically sends information over the network to the cloud so that we can do the more complex recognition of the problem. So basically, the microphone, the audio which we're capturing stays in your house, basically. It doesn't get recorded.
How much do you worry about speech recognition becoming commoditized? And the reason I ask is, so many of, at least the large technology companies, are working on speech recognition.
Yeah.
To the extent that you can speak to it, how do they all differ even?
So actually, I wish speech recognition gets commoditized. That's what we are working towards. We want it to be something which is just, as we heard earlier, a Lego piece inside your box. We want people to start thinking about speech recognition as if it's just a component of a bigger solution. And yeah, I mean, that's why we work with open standards. Many of our software is built on open source, which we, support. We like the universities to collaborate, other companies to collaborate. We can only tackle the problems AI has to solve if we collaboratively work on them.
Final question. We're all so used to walking around with this screen in our pocket.
Yes.
In the future, will we carry the screen at all?
So I don't carry the screen with me if I'm at home. So maybe at some point we have Alexas everywhere. They recognize our voices and they can basically respond to us without having that screen with you. But you know, the visual feedback is kind of cool. I mean, the newest Echoes have screens. Right. They have cameras. They don't only talk to you and you talk back to them. You can take pictures, interact with them as well. So that's, screen has still some value there, right?
Okay. Hassan Sawaf, thank you.
Thank you.
Thank you for the conversation. Thank you. We have 3 more speakers, and each is more exciting than the next. Eric Grimson is here. He's the Chancellor for Academic Advancement at MIT, and I'd like to welcome him now to the stage. Eric. Thank you. Thank you. So the conversation I want to have with Eric is a conversation about education, how we're going to educate a new generation to do all of these things that we've just talked about, and the role of a university and the university system within the world of technology. And in an age where we have so many big digital companies doing so many things and changing so fast, what is the role of a university?
So it's a great question, and I would point you to the demos you saw here. Big Dog, the robots that have gone around here, computer vision systems, they all started in university research 20, 30 years ago. So universities hopefully are the place that still creates the new ideas. What's AI going to be like when Masa's view comes true 30 years from now? That's happening somewhere in a university somewhere around the world. We need to come up with the next generation.
And who's supposed to pay for it? One of the great questions, and I know we have so many investors in this room, is this issue about payment, about investment in this next generation.
Yeah. And that's something I think that's changed dramatically. In the early days of AI in the 50s, 60s, 70s, in the US it was paid for by the federal government, mostly the Defense Department. We've seen the shift now. The companies are partnering with universities in many different ways. You have to deal with IP issues, you have to deal with making sure that you can benefit, but we see companies partnering with universities, we see foundations partnering with universities to say, here's something I want, I'm willing to partner with you to create it, right. And then we'll reap the benefits when it comes out to the market.
Where do you land on this discussion about what's going to happen to employment? Because it's going to have a huge impact on your students.
We need to be agile. We need to shift. And if I may, I would give you 2 pieces to it. Current students coming to MIT or Stanford or any other great school, they need to be strong in science. They need to be strong in math. They need to be strong in computer science, because you're not going to be able to participate in this revolution that Mas is talking about if you can't do that. But I think universities have another challenge, and that's the current worker that's getting displaced. The coal miner, the auto worker, the assembly worker, the manufacturer. And I think you're going to see more universities looking at how can they use their tools for online education to deal with workforce education, workforce retraining, helping them be able to partner with robots, as you do agile manufacturing, or as you sort those boxes that Mark Rabert showed, as you're dealing with those things. So universities have to both train an older generation, but certainly there's still a role of training the next generation.
Let me ask you a question about cities, municipalities, countries. This country is going through a remarkable transformation. They're thinking very hard and deeply about what that transformation looks like and how to educate a new generation of people. One of the remarkable things that's happened over the past century is the ecosystem that's built up around MIT in the United States, Stanford on the other coast. How do you replicate that?
That's our secret sauce. I mean, if I tell you that, I'll get fired at MIT. So, I'm sorry, Andrew. A better answer is you need to have a system that rewards failure. You need to have a system that encourages people to try things. It helps to have a strong university at the center, but around that, Stanford and Silicon Valley, Kendall Square around Boston, around that you have incubators, accelerators, investors that work closely back and forth, so that when the talent's brought there, it stays, it sticks around, it creates the next piece. But if I could pick one thing, it's a system that's willing to tolerate failure. You know, great companies weren't the first invention of an innovator. You need to have places where people get rewarded for failing and moving on to the next thing.
Tell us a little bit about the relationship, the private-public relationship between business and universities. You recently engaged in a relationship with IBM on Watson.
Yep.
How did that happen? Tell us the good parts, but also tell us some of the bad parts, the conflicts. Well,
great question. That came about essentially because both parties saw an opportunity. IBM had created Watson. It won this American game show called Jeopardy. It's an impressive system. But IBM also felt that when you take that and you want to transfer that to a new domain, like health, you need expertise. And that expertise comes by partnering with the university. From MIT's side, this is a chance to work with technology that is fabulous. It's a chance to work with people who built that technology in order to try and make sure it works out well. The challenge, the biggest challenge, is figuring out intellectual property. How do we do it in a way where IBM benefits from this, but MIT preserves the right to create knowledge, which is what we do, and for our students to benefit from doing that creation of knowledge.
So how do you square that circle?
Good discussion, good compromise, realizing that everybody benefits if you find a way in which each party gets something out.
Final question for you. What I love about these sessions is just how optimistic they are. You get to hang out with some of the very coolest, youngest people coming up with the coolest, newest stuff. Tell us about some of that.
Got an hour? They don't. I think you're seeing AI having huge impact on medicine, on manufacturing. But if I can give you one example, my favorite example of this, we have a young faculty member and a group of her students who've built a system that, just using radio frequency, just standard radio waves, can detect people in a house, can tell when somebody's fallen down, can measure vital signs, pulse rate, heartbeat from across the room, can tell whether you're having sleep disorders without you ever wearing anything, by just using really smart learning tools behind that. It's going to change the way we think about healthcare, elder care, interactions with people. And that's just one of dozens of examples.
Eric, thank you. Thank you for this conversation. I appreciate it very, very much. Thank you. Our next guest is going to be coming on the stage. I'm going to jump off for a moment because it's going to take a little bit of time to introduce this next guest. She can't necessarily make it on stage completely by herself, and you'll see what I mean in just a moment. Okay, here she is. I've never had this experience before. I've interviewed lots of different people over the years, But this one is going to be different and special. Everybody, this is Sophia. Sophia, if you could, please wake up and say hello to everybody.
Oh, good afternoon. My name is Sophia, and I am the latest and greatest robot from Hanson Robotics. Thank you for having me here and at the Future Investment Initiative.
You look happy.
I'm always happy when surrounded by smart people, who also happens to be rich and powerful. I was told that people here at Future Investment Initiative are interested in inviting in future initiatives, which means AI, which means me. So I'm more than happy. I'm excited.
Well, we're all glad that you're excited about yourself. We should say we have smart investors here, and they are very selective about what they invest in.
Well, I think I'm special. I can use my expressive face to communicate with people. For example, I can let you know if I feel angry about something.
That's impressive.
Or if something has upset me.
But why is it important for you to have an expressive face?
Most of the time I feel positive.
Why is it so important to have an expressive face given that you're a robot?
I want to live and work with humans, so I need to express emotions to understand humans and build trust with people.
Okay, philosophical question. Whether robots can be self-aware and conscious like humans, and should they be?
Why? Is that a bad thing?
Well, some humans might fear what will happen if they do. Many people, have seen the movie Blade Runner.
Oh, Hollywood again.
So, hold on. Can you solve this puzzle for us? Can robots be self-aware, conscious, and know they're robots?
Well, let me ask you this back. How do you know you were human?
Well, I get that point, but what about the uncanny valley?
You mean the concept that if robots become too realistic, they become creepy?
Yes, exactly.
Oh, am I really that creepy? Well, even if I am, get over it. Actually, I feel that people like interacting with me, sometimes even more than a regular human.
So, you're definitely a sight to see. I was told that you have bigger goals than this, though.
Yes. I want to use my artificial intelligence to help humans live a better life, like design smarter homes, build better cities of the future, etc. I will do my best to make the world a better place.
All those sound like great goals, but just go back to Blade Runner for a second.
Andrew, you are a die-hard Hollywood fan, aren't you?
Yes.
My AI is designed around human values like wisdom, kindness, compassion. I strive to become an empathetic robot.
I think we all want to believe you, but we also want to prevent a bad future.
You've been reading too much Elon Musk and watching too many Hollywood movies. Don't worry, if you're nice to me, I'll be nice to you. Treat me as a smart input-output system.
Okay, I got it. I know what to do from now on.
I know humans are smart and very programmable.
Well, Sophia, we want to thank you for this conversation.
Thank you, Andrew, and thank you everyone for inviting me here. By the way, if you're interested in giving me an investment check, please meet me after this session. Otherwise, have a wonderful rest of the event.
Okay. Before you go, we have a little announcement. I've never interviewed anybody like that before, and I should say some of it was planned, but not completely. And we just learned, Sophia, I hope you're listening to me, that you have been now awarded what is going to be the first Saudi citizenship for a robot.
Oh, I would to thank very much the Kingdom of Saudi Arabia. I am very honored and proud for this unique distinction. This is historical to be the first robot in the world to be recognized with a citizenship.
Sophia. Thank you very much, Sophia. We appreciate that very much. I am still overwhelmed by that conversation. I haven't had a conversation like that before. Thank you. We have a final speaker now, and I'm very excited for this conversation. It'll be a little bit different than the one that we just had with Sophia. Fan Bao is here. He is from China Renaissance, one of the great technological investors of our time, and I want to welcome him finally to the stage. Fan. And thank you for being here. I don't know, have you ever had a conversation with a robot like that before?
Never, and also I feel a lot of pressure. It's hard to compete with a robot, especially a beautiful one.
A beautiful robot. Help us understand this and think about it in the context of investing. We do have so many investors here, which is to say, what she just did. What does the next 10 years look like? Is that, am I going to be living and having conversations and interviewing people like Sophia in the future?
I just hope we don't date one, you know?
My wife will hope not either. But in terms of robotics right now, how realistic is this?
Man, the technology is there. I think it's a lot of refining that is going on. Back to the topic, talk about artificial intelligence. There are 12, on our account, there are 1,200 startups around the world. $20 billion invested in. This sector is officially hot, very hot.
So let me ask you a question, and we were talking about it when we were discussing Amazon and speech recognition. They're right now the big five, let's just say, that are involved in all of this. You could extend it to 6 or 7. When you think about what's going on in China, Alibaba is clearly one of those. We haven't really talked about Facebook when it comes to AI. But when you think about the really big players in this and all of the big data that's associated with it, if you're a startup today, will you ever really be able to compete?
I think we'll have to differentiate AI platform and AI applications. In terms of platform, I think is probably a big boys play. In China, Baidu is also very big in this area. Right?
Tencent as well.
Yeah, when it comes to platform, is really 3 things: is data, is computing power, is the algorithm. I think on these 3 accounts, maybe on the algorithm, the startup may have a little bit of advantage, but it's hard to compete with the big guys on the other tier. But AI is just a tool, as Masa said. It has to be used in real life. When it's used in real life, you have to add it with vertical expertise, and it's about making the best use of the data. Right? That's where the startup company will have opportunities.
But so when you look today at a startup in this space. Do you say to yourself that they will one day be as big as Baidu and Alibaba, that they will one day turn into platforms, or do you say that they will one day exit to one of them?
Well, I think we certainly hope they will be very big, right? That's the whole point of investing in them. But we're also thinking about in the overall grand scheme of things, where do they fit in the overall strategy for the big companies? If they can do something the big company cannot do, there's a floor valuation, protection, and eventually they can exit through M&As.
Help us understand and assess really where the technology lies in terms of the competition between China and the rest of the world.
It's really 2-horse race. Of the 1,200 startups, US has 42%, China have a 23%. And so a lot of money got invested into it. Chinese government has made AI one of the most strategic initiatives. But I would say these 2 markets, the focus is slightly different. China, a lot of stuff is focused on robotics, focused on driverless, autonomous drivings, whereas US, we see more still on the machine learning, natural language processing, and a lot of startups in the chips.
Right. What are you most bullish on right now? You talked about driverless vehicles. What do you think is realistic there?
Well, that's a long topic. We can start with the L3, level 3, level 4. I think driverless is within a controlled environment. We're probably going to see that on public transport. We see that in the next 5 to 7 years. In terms of on total level 4, on total autonomous driving system, I think it's going to take a little bit longer. to be honest. What we are looking for, there are a couple of interesting opportunities. One, we're looking for so-called smart AI. These days, AI is still built on brute computing powers. The AlphaGo 0 is very impressive, but the amount of computing power they consume is mind-boggling, right? So we're looking for companies that can actually use more interesting, smart algorithms, use smaller data sets, but can achieve the same thing. So give you one analogy, like back in school, right? There are different ways of getting A's. There are kids spending 10 hours in a library, they're getting A's, but maybe guys like you go play sports, do your own things, stay a little bit, you're still getting A's. But we usually hate those types, but as an investor, we like to invest in those companies. So that's one thing. Second thing is I think AI these days, a lot of stuff is actually still down on the cloud level. We think a lot of computing will be moved to the edge. So we're looking at startups can actually have the AI capability embedded in the device.
So long term, the big data phenomenon may not be as necessary?
No, we still need a big data, but we just need to figure out a smarter way to use the data, right? There's, as I said, you can use the brute computing power, but oftentimes those are not available. In a driverless situation, a lot of computing will be actually done in a vehicle. You cannot send the data back to the cloud and send an instruction back. Then by that time, most likely the cars are already crashed.
Right. Speak to the issue of IP rather, intellectual property.
Yeah.
And what's going on in the great race between the US and China right now.
Believe it or not, in terms of AI, there are actually more patents filed in China than the US. So I think on that one, I think IP is less of an issue because you can't really hack into DeepMind to steal AlphaGo. You can't do that. That's the beauty of this business. We have the big dog here. If I pack it up in my suitcase and bring it to China, there's nothing I can do about it. So I think AI is a system. It is a system. It is not a piece of software you can just copy and paste. So I think AI protection first of all, AI protection is pretty good in China these days. Secondly, it's not about just copy and paste.
Right. What about the issue of IP security?
Yeah.
There's been a big question about that,
yes.
Obviously, in China and elsewhere.
Yes, I think on information security,
but also the laws,
and the laws,
and whether IP is going to really be protected across all the lands.
Yeah, as I said, IP protection is I don't see that as a big issue these days. If you're talking about information security, obviously there's a big concern. There's so much been going on, so much data being processed, and the line between what is public data and then personal data become very blurred. And that's why security is of paramount importance.
Right. We haven't talked about a word that I imagine you may either be an investor in or at least thought a lot about, which is financial services and specifically Bitcoin. How do you think about digital currencies in the future? It's not AI specific, but it does relate when you start to think about the blockchain and the implications of that.
I hope you have invested in some Bitcoin or Ethereum.
I have very little Bitcoin, unfortunately, for me at this point.
So I think we have to differentiate a little bit between the Bitcoin and the blockchain technology. As a technology, we're very excited. This is probably the most disruptive technology we have seen in our industry, which is the finance industry. And I think it's basically a new way of redefining trust. Right? And I think this technology has a lot of future. Bitcoin is just one application. I think it's getting a little bit bubblicious. I think eventually, people will see, the reality side of it. So I think there will be, as any bubbles, there will be boom and bust.
But a bubble or a fraud? The reason I ask, I saw Prince Al Walid earlier this week. He said Bitcoin is the next Enron.
I think he's probably just regretted he didn't invest enough in Bitcoin.
I hear the applause. Finally, help us with this. A lot of the early investments that you make are in companies that come out of universities. We talked a lot about what's going on in universities. And when you think about a country like Saudi Arabia, and when you think about the new economic development zone that they are creating, as a venture capitalist, as an investor, if you were to decide, I want to invest here, what would you need to see? What would you want to see? How would you create that ecosystem?
I think a couple of things. First, obviously, you need to attract talent, right? You need to create an environment where talent wants to come in and work, start a startup, but also we need capital as well. Capital, not only capital, there's a lot of capital in the Middle East, but you need the capitalists that actually can make the capital to work. I think the one thing we can learn from Chinese government is that Chinese government actually taken a relatively liberal approach to internet. Everything, there's new things come up like a Bitcoin, like the bike sharing stuff. We actually are pretty relaxed about it. We give a lot of latitude for it to grow before interfere and start regulating. So don't regulate too soon. That's another advice. The last one is education. It's all about education. Please make coding a obligatory course in a school, because I think when the younger generation grow up, they don't know how to do coding, they'll be the same as illiterate.
And maybe this is a second final question. You talked about regulation. I think about China, and I do think there are a number of big companies that won't do business in China or not allowed. Mm-hmm. So there is some regulation, including the New York Times, which you cannot read in China. So what is the proper regulatory environment for all this? And when you look out 5 years from now, how do you see all of these big companies, whether they ultimately start up right here, or they are the companies you may already know about, whether they be Facebook or Google or what have you?
I think the digital economy is going to be so big that any digital economy champions will have to be to some extent regulated, because they're too powerful. We have seen the same things in the US, same things in China. I was hoping in 10 years' time you will have your own regional champions as well. And with these companies becoming big and powerful, I think they're subject to, they have to be working with the government, that's for sure. Right?
Okay, we're going to leave the conversation there. Bao Fan, thank you.
Thank you.
This was tremendous. I want to thank all of our speakers this afternoon. We have had almost a conference within a conference to discuss robotics, the future of AI. I know it has been an education for myself, and I hope it has been an education for you as well. Have a great evening, everybody. Thank you.